Welcome to the demo part 2. In this part, I will demo a parallel in-database implementation of linear chain conditional random field learning and inference for part-of-speech tagging. Let me first give a brief introduction to MATLib and CRFs. MATLib is an open source library for scalable in-database analytics. It provides data parallel implementations of mathematical, statistical, and machine learning methods for structured and unstructured data. As one of the contributors, we develop learning and inference modules for part-of-speech tagging using linear chain CRFs. CRFs are the state-of-the-art probabilistic graphical models on a number of real-world tasks, including part-of-speech tagging and name entity recognition. Now I will demo two APIs supported by MATLib for part-of-speech tagging. The first API is for parallel linear chain CRF training. CRF training is a convex optimization process involving multiple iterations. We use a Python UDF to drive the computation. Within each iteration, we use user-defined aggregate functions to parallelize the computation of the log likelihood and gradient vector over all documents. At the end of each iteration, the weight vector is updated using limited memory BFGS convex optimization methods. The first function is CRF train data. This function loads training data from the file system into the database. We're loading about 200 trained sentences from the Connell dataset. We're done. It took about 11 seconds. The next function is CRF train fgen. This function generates all the features from the training data. And these features include regular expressions, sentence edge features, dictionary features, and several others. We're done. It took about 9 seconds. The third function is lincrf. This function optimizes the CRF model using limited memory FB or BFGS convex optimization methods. You can specify the number of iterations you want to run. Here, we chose 20. After 18 seconds, we're done. And now we have a trained CRF model loaded into our greenplum database. This is the end of the first API. The second API is parallel top-1 linear chain CRF Viterbi inference. The Viterbi algorithm is the popular choice to find the top K most likely labelings of a document for CRF models. We chose to implement an SQL statement to drive the Viterbi inference. In greenplum, our SQL statement is inherently parallel due to the set operations over relations.